division of polynomials, and we're also going to use synthetic division stuff. Okay? That's wipe out.
Okay.
So when we did long division, remember I kind of showed, didn't I show you guys the other day how long division can look with polynomials?
Yeah.
It looks horrible, but it's actually quite simple. So what I want to do is a quick reminder of how you do long division. So let's take 37,634. Let's divide that by 12. We're going to divide that by 12. So does 12 go into 3?
Yes.
No. Does 12 go into 37?
Yeah.
How many times?
3.
So we put a 3 above the 7 because a 12 goes into 37. What's 3 times 12? 36. We subtract it. What are you left with?
16.
1. All right, so let's try that again. We're left with 1, and then what do we do with that 6?
Drop it.
We drop it. Now we have 16. It's okay if you're talking. So now we ask the next question, does 12 go into 16?
Yeah.
How many times? Once. 1 times 12 is 12, subtract it out, we get 4. Drop the 3.
I'm so lost.
Yeah, like we didn't learn how to do it.
This is how it works, because this pattern works with long division then. 12 goes into 43, how many times do you think? Well, 4 would be 48, 3 would be 36, and then we have 74.
8, 6, 8.
7, 5, 3, 0, 9.
Wait, 8. Wait, where's the 74? Why is that 74?
It's 6.
43 minus 36 is 7, and then I bring down the 4.
Okay.
6.
6!
So it's 3,136.
And there's a leftover of 2, right?
Yeah.
Back in the day, you'd say R2 for the remainder of 2, but we also know that that means it's a fraction, right?
Yes. No. 1/6.
1/6, yes. This is also a fraction because this is in 2/12ths, but we would write that as 1/6. Decimals are for chumps, as a student once told me.
But I don't know.
I'm not worried about decimals here. So,
3,136.
and a 6, yeah. What you're doing here when you're working with long division is you're working with each individual term to set it up. It works exactly the same way when we do polynomial. So here's how I want you guys to write these out. Don't write them out horizontally. Set it up automatically to do the long division. And here's how this is going to look. 2x plus 3 goes out in front. Inside here, we write into a descending order with placeholders if necessary. Okay. Remember, placeholders go if we're missing a power, we're missing a degree, but here we have a 3rd degree, 2nd degree, 1st degree, and a constant. I don't have to worry about any placeholders. So I put in 2x cubed minus 7x squared minus 17x minus 3. And when we're using long division with polynomials, what you're trying to do is eliminate terms. Okay? You're really only looking at 2 things. You're only looking at this part here, the 2x, as it's going into each of these terms. That's all you really have to look at. And you're going to, what's that? I'll show you. So here's what you do. We have a 2x, it's got to go into the 2x cubed. What do you multiply 2x by to turn it into 2x cubed? Just x squared. Maybe we should have 2 questions. Oh, too soon? Oh. I'm sorry, Izzy.
Got her.
I'm sorry, that was me.
You won anyway.
So is everybody agree to turn a 2x into a 2x cubed I have multiplied by x squared?
Yes.
All right. Where do you think the logical place to put x squared would be over which one of these numbers?
2x3.
Put it over the x squared. So if I'm multiplying it by an x squared, I put it over what I'm multiplying by.
Okay, I see.
You guys, this is the first time, really the first time you've seen it, so just stop your complaining until the end. Multiply this, both of these, and you get 2x cubed plus 3x squared. Do you agree? All I'm doing is just distributing them out. Subtract them both. What's 2x cubed minus 2x cubed?
3. 0.
0. Negative 7 minus 3.
Wait, where'd you get the annotation in red? Right under it that you're subtracting?
X squared times this.
Okay.
So I get negative 10 x squared, right?
Wait, why isn't it?
Wait,
Negative 7 minus 3. Yep. Drop the 17x. Now I'm going to ask, how do I turn a 2x into a negative 10x squared? Negative 5x. Take the negative 5x, multiply it to the 2x plus 3. You get negative 10x squared minus 15x. Okay. I'm subtracting these guys out. First term goes away. This becomes negative 17 plus 15 gives me negative 2x, and then bring down the negative 3.
You tried.
That's okay. Exactly. And now to eliminate the negative 2x, how do I turn a 2x into a negative 2x? Multiply it by what, Maggie? Negative 1. Multiply that out, you get negative 2x minus 3. You subtract it out, you get a 0. There's no remainder.
Wait, you add them?
Wait, what did you do with the negative 1?
I wanted to turn the 2x into a negative 2x, which means I multiply it by negative 1. I distribute it out, I get negative 2x minus 3. When I subtract it, they go away. Yes, sir?
The thing that confused me was how negative 3 times negative 5x ended up being positive 15.
I was subtracting a negative 15. So this right here was negative 17 minus a negative 15.
Yeah.
So I did same thing twice.
And why didn't you do that for x squared?
Because I knew that was going, if I did that, it's just going to be 0. I just said it. That's all. My goal here is to eliminate that first term each time as you're subtracting through. Okay? You will always need it. You're always going to change this into something. Yeah. Okay? See how I have two terms here? So when multiplying it twice, you're always going to wind up with two terms as you're going. Yes, ma'am?
Will it always work out like that? They do 0 at the bottom?
No, because you can have a remainder. You can make a fraction. It's very easy. Same thing as you would have done before. So it's the same idea. We're going to go long division here. We're going to take a 4-term divided by a trinomial. So you put the trinomial on the outside. We have x squared minus 2x plus 2. 2x to the 4th plus 3x cubed plus 5x minus 1. Once again, I did not need to worry about any placeholders because I have a nice descending degree here. You don't have to worry about it. All right? Oh, forgot that.
Now what do I do?
We put a 0x squared in. Sorry, thank you for paying attention to me being nonsensical. Sorry about that. So, I must have looked up and I saw the x squared there. Whatever. It's tough getting old.
How old are you?
Old enough. So, first question you're going to ask, how do you turn an x squared into a 2x to the 4th? 2x squared. So which one of these am I going to put it over?
X squared.
Very good. I'm going to put it over the 0x squared. So I have a 2x squared here. Distribute the 2x squared to the trinomial on the outside. You get 2x to the 4th minus 4x cubed plus 4x squared. We're okay with that?
Yep.
So you just 2x squared over here. Why does it matter
Yeah.
where you put it?
Well, if you look at it, how many terms do I have on the outside?
3.
So when I'm multiplying this out, I'm going to have to multiply it to 3 terms. It just winds up it should be over the same value. So now when you put that out there, you subtract out all 3 of these parts. I have a 0. 3 minus negative 4 is 7x cubed. 0 minus 4 is a negative 4x squared. And now I just bring down 5x. And then go ahead and say it. What do I multiply by? 7x.
Are we trying to turn the x squared into the 7x?
Yes. You want to multiply. You want it to turn into the exact same value. Okay. You don't want to make it the opposite sign. You always want it to be the same value because you will be subtracting in a second. Okay. So multiply by 7x. So I have 7x cubed minus 14x squared plus 14x. We're slowly eliminating terms. Subtract those out. The 7x's go away. I have negative 4 minus negative 14 gives me, very good, 10x squared. 5 minus 14. And then I just bring down the 1. Or excuse me, negative 1. How do you turn an x squared into a 10x squared?
10.
Multiplied by 10. So then we have a 10x squared minus 20x plus 20. Subtract everything out.
Negative 20, no, 11.
11x, very good. Minus 21. Now what? Now that's like a remainder then, isn't it? So is that remainder, is that 11x positive or negative? It's positive. Since this is positive, all you do is plus 11x minus 21 over x squared minus 2x plus 2.
Whoa.
And that's your remainder. It's the same idea as when we were dividing by 12. We had 2 as a remainder, so it's 2 over 12. And just rewrote it as 1/6. Here, I know that I'm not going to be able to simplify it. And I'm done. Yes, ma'am. If this winds up being a negative, instead of putting a plus sign here, where are you going to put? Yeah, that's all. Yes, ma'am.
Is there always going to be like, you can't simplify it?
More often than not. I can't remember, I'm sorry. I can't remember one off the top of my head that you could simplify. But that's what you're looking at doing here, guys. Simplistic long division. Okay? You want to try one on your own? Means I have to find one. Oh, there's a 0 here. All right, so we have an x plus 4 into x to the 4th plus 0x cubed minus 16x squared plus x plus 4. I remembered my 0.
Yes.
All right. X into an x to the 4th, what do you multiply it by?
X to the third.
X to the 3rd, good. So I put it above the x to the 3rd. I get x to the 4th plus 4x cubed. I subtract it out. I have negative 4x cubed minus 16x squared. Now you're multiplying by negative 4x squared. So you have negative 4x squared. So you have negative 4x cubed minus 16x squared. When you subtract that out, you have 0x squared, right?
Yeah.
Okay. Drop down the next number. Drop down the x.
Oh.
Now you have to multiply. When you multiply x by, you turn it into a 0x squared.
0x.
0x.
Isn't that just same thing, same as 0?
It is, because now watch what happens. When you multiply it out, you get 0x squared plus 0x. So when you subtract it, you're left with x plus 4.
So could you just skip that step and drop down the next two? Because that's what I did.
You can, because now what do you have left?
1.
Plus 1. And doesn't that work where it drops it out, where you have x plus 4? So your answer then, when you divide it out, you would have x cubed minus 4x squared plus 1. What happens here is you're right. Like you were saying, you could skip that because you might have zeros there. It's holding a place is all it's doing. It's just doing a quick little placeholder there. All right? You don't have to put the x there. You can leave it like that if you want. I'm fine with that. I'm perfectly fine with that because it helps. If that helps you to see that there was a 0 value there, you can leave it like that. Okay? I don't have enough time to do synthetic stuff here today, so we'll stop with just long division stuff today. Is that all right? Yeah. Let me give you a few of these to try. So this is 6-5 now. What is this, 356? So we're just going to do long division today. Section 6.5. I think it was 356, I believe. Yeah, 356. Let's just do...
All of them.
No.
All of them.
Who just said that?
Do 17.
17 questions.
6 of them?
Sure.
Is that okay?
Yeah.
Hey, that's like 3 pieces of paper.
It shouldn't be 3 pieces of paper.
Here, I'll finish. Do 18.
It's 7.
Oh, yeah, it's 7. I can't count, remember?
It's okay.
17, 18, 19, 20, 21, 22, 23.
So if we just do
What, you
17
spelled that?
skeleton.
20 pages.
All right. You should get that on one sheet. Put it on, sure.
Whoa, this is cool. Whoa.
Can you see that okay? Do you want me to?
Got it.
I'll blow it up.
Okay, oh, that's 2 words. Jane, you messed up.
It's not like you to get to 23 right now. I already know that anyway.
Wait, what?
All right.
So, 23?
Yeah, 23. It just looked weird.